password. This is to stop unauthorized users from accessing. The password is 144. Actually, what I will do here, actually, actually, cross out, so password 144, remove the 744, that would give them too much access. It's not a problem, but 144. Okay. This actually has a really nice summary for a basic user.
Yeah.
Everything I'm going to explain is saying there.
Yeah.
So password is 144, you press the trigger and you get into this mode. Okay? And essentially, I've done like you said, well, we've got a test sample that always comes with an instrument, but I will use it. So you're in this mode. You have, so the way what you have to see here, this little slot is where the measurement takes place.
Yeah.
This big circle is the camera, which we will look at in a minute. Okay? All right. So what I do, I have to put my sample, my piece of scrap in contact with the object, press the trigger, and just wait for it to finish. It takes a few seconds. And here's what I get on the screen. It's telling me that it's a grade of 7075 with all these elements. I'm going to just change this, which is 90%, 90.8% aluminium, 5% zinc, and you can see that is the grade of metal, 7075.
Yeah.
The little number on the side here gives you the match quality. Okay, so the closer to 1 this number is, the better it is. Below a certain...
So mistake range is 5% at this, in this case.
So it's and the way it works, the way it calculates it, you can see each alloying element, and of course there's a number, to match, so it gives you where the reading and the error of the measurement. There's always an error in every measurement. And you can see in this case, the zinc is close to the limit, and the specification for this alloy of zinc is 5.1 to 8. I can't really, sorry, I haven't got my glasses, 6.3, and the reading is coming at 5.09. So the zinc is just on the limit, but everything else is green. So yellow means at the limit, but okay, green perfect, and it's almost a perfect match. Like all these things, especially with scrap metal, as you know, a metal to fit a grade, the concentrations could vary a little bit. So you can see now it's reading 5.14. So the zinc is probably a little bit low, and now I'm getting a perfect match. And this is a simple operation of the system.
100% clean.
Now, if the match goes below a certain value, it will not accept it. It will say I cannot match it. Of course, what the analyzer is doing is matching to a library of grades inside the system. Maybe 2,000 metal alloys.
Is it connected wireless to library or how?
The library is in the system.
Inside.
But I can show you after. This is for a more advanced user. If you are missing, if for example you realize there is a grade, of course not every alloy in the world is in the library, it will be too much and it confuses the users.
7075. I know this.
7075,
military grade alloy,
Yeah, that's right, or aerospace. It's a good aerospace. We use it as a quality check because it has a lot of elements in it.
We make it.
Okay. So now what I can do, I've got a range of samples here. Just to show you. So always the same procedure. You put the sample in contact, you press the button, you press the button again, and you get there you go. Now we have an 1100 aluminium.
It's 99. 0,
yeah. It's the 1000 series of aluminium high, and you can see 1100. It's the right grade. Okay.
And these etalons, we don't need etalons. They are all.
These are mine. It's when I'm doing a demonstration. If people don't have any samples, so here, for example, I've got a Monel. Again, I put it in contact.
This is monetary alloy.
You will soon say this is a completely different alloy.
This is zinc.
Alloy 400. It's a high nickel alloy.
This
completely
is
different.
For coins.
It's used. I've got these samples because we make high pressure reactors. So, but I've got, for example, I've got all sorts.
You make high pressure reactors.
Yeah.
For chemical industry.
Yeah. But not mostly for laboratory and pilot. Now here's again a different one. This is a nickel chrome with moly, alloy 2000. I've got my glasses in my pocket, but I mean I know it is an alloy 2000. You can see it there.
Yes, C2000. Yeah.
Yeah. So.
And range is again for chromium range is.
So you can see there's a range of 22 to 24%.
Yeah.
And nickel is 48 to 68. Moly 15 to 17. Copper 1.3. So.
And can you correct this yellow one again?
Well, at the end of the day, the fact that it's yellow means that the error margin of the measurement is close to the limit, but we are within spec. I mean, the system is giving you a match. I mean, I can try something quite different. Let's have a look. Just have to make sure I've got. Unfortunately, something I messed up that, so now I'm going to do something a bit different. So this is now stainless steel. It's a 301. I'm going to try now a piece of. There you go. This is something different again, just to give you a feel for. Yeah. Now this is titanium alloy. Yeah, it's a titanium CP. That's.
So you do basically all non-ferrous metals and steel.
Yeah. Well, all this little box allows me to have a nice little range of samples. Now let me just look here.
Tin.
Well, to be honest, tin. I don't know if I've ever done any tin alloys. So now this is an aluminium bronze.
Yeah, bronze. I wanted to say. Yeah.
So you can see that's again as a C6, 642.
Yeah.
So
you can do bronzes, brasses.
Brass, bronze, gunmetal. I mean, it is calibrated. So you can see that's the really basic use of the system. You go around, you press the trigger, and you get a reading.
And do we need calibration occasionally, or?
You never need to calibrate the system. What you do need to do, what the user does need to do, and I would recommend it to do it on a daily basis.
Okay.
Is when you first use it. So that's a simple operation of the system. But this button here, or using the touch screen, you can do both. So if you're wearing gloves, for example, you press here, it takes you to the main menu.
Yeah.
Analyzes what we've just done. Yeah, so I'll do it again, just do one more reading. Press the trigger, and I get my reading. Okay?
Yeah.
If I press the trigger, it goes back to analyze, ready for the next measurement.
Yeah.
If I press on this menu, of course I have got different things I can do. One of them is called a system check. Can you see that?
Yeah.
System check. Only this sample should be run.
Only this one, yeah.
Yeah, and it's in the box.
Yeah.
Well, you will get a fail if you don't run that. Okay. And then you get a pass. If you get a pass, it's
and
good.
it is kind of physical password for all alloys.
What it's really doing is checking two things: that the peaks are in the right place, and that the intensity is about correct. So the system, as long as it passes this test, it will last forever.
It's then calibrated and recognizes everything in the library.
Yeah. So there's no need for calibration. There's no need for anything. Of course, if let's say if something happens, or and you press and you get fail, then you need to get in contact with us. And I will show you a couple of things you can do from a diagnostic point of view. But realistically, that's all you need to worry about. So I will put this sample back here.
Okay.
Now, that's as simple as it gets. For a basic user, that's all you need to do. Two very important rules. Number one, make contact with this point. Okay. I will show you with a sample what's actually happening.
I'll do myself once, twice.
Of course, you'll show. Yeah, absolutely.
After I make the film.
Yeah. So I'm going to show you what's actually going on with the laser. Have a look between there. Can you see?
Yeah.
But the way the system is designed, so now, so I'm still in system check mode, and this is the kind of error you get but I've run the wrong sample, what I should have done. But I just wanted to show you. So this laser is going up and down. The sample has to make contact, so you cannot hover.
Yeah.
Okay. If you're getting a piece of swarf, take a little piece and put it. Yeah. Now, there is absolutely no danger. Yeah. I'm going to put my finger, start the measurement. It does not do anything. It is totally harmless. What you must not do is point it to somebody's eyes. It's a laser. Okay. Yeah. So that's the only thing. And when I put it to my finger, this is what I get. This is a tip.
Sugar level.
Yeah. Yeah. But you don't feel anything. And that's when people say sometimes, could you analyze wood or could you analyze plastic?
Yeah.
No, you can't, because
it's not a library.
well, no, it's not even that. It's what's happening when the laser, the energy is just dissipating in my finger.
Yeah.
So I don't feel anything. With a piece of metal, the whole energy of the laser is on the surface, and it creates what's called a plasma, and that's how it does a measurement. But it can only happen on metals. You can only analyze metals. Okay. So what have I got? I've got a couple of interesting samples. Where is it hiding?
Zirconium.
I don't have any zirconium. No, that's. I've got a beryllium copper.
Oh, beryllium copper.
Yeah, because this measures beryllium copper very well. Well, I can't see it. It's not.
Zinc alloys as well.
Yeah, zinc. Well, let's have a look. I think I've got a zinc. Oh, there you go.
Here.
Maybe it's
this one. Should be here.
It should
this
be.
One.
Yeah, let's check it. Is it the zinc? Oh, yeah.
Zamak, I guess.
So then it will recognize it as a zinc alloy. You do not have a full library. It will just identify it as a zinc alloy. Okay.
Is it possible to upgrade the library to zinc?
In order to do that, we need some zinc standards.
Okay.
There's things like lead and zinc. It will recognize it as a
base
material, but it will not give any more.
Okay.
Right. So that really, for a basic user, you do your daily check in system check, and then you go back to the analyze mode, and that's it. Sample has to make contact. Now, let's say, for example, you've got an argument with a customer about your scrap. What you can do is, before you press the measure button, if I press this, if I press the side button in this direction, I can enter a sample ID.
Okay.
So I could call it whatever I want.
Yeah.
Okay. But what I can also do is take a photo of the sample.
Oh, okay.
Okay.
And you have it in the library for some period stored? Or?
So yeah, but every result is stored. So now I will take a picture of my sample. Okay. And I accept it. You can give other details. You can see there's you can fill all these things. Okay. Then when I do my measurement, all this information will be stored together. Okay. Right. So there is a menu called View Results, and you can now see all the measurements you've done. Now it logs everything, and you can see now this sample I called DSWC is listed there.
Yeah.
Okay. I can go and have a look at the reading. I cannot access the picture from the phone. That I have to download to my computer. Okay.
The download connection.
It's very easy. Yeah. You can. I will show you this next. But what I'm showing you here now is the ability, and you can see the information is still stored there. The pictures there. Now, what I can then do, is so when you do a measurement, you can actually do test after test after test. But of course, if you don't put any identification, the library is full of results which are not identifiable. So if you want to trace your readings, you just click on either the left arrow or the left button, and it gives you access. Okay. So we'll accept that, and off we go.
Is there any detailed manual on your website, or is it just?
Yes. Okay. So there's a couple of things. So this is a quick guide.
Yeah.
For maintenance, what you've got. So here, in this, are two things. There's the software for the library, and there's also the manual in PDF. Okay, this is all in here.
Okay.
For maintenance, you've got a couple of things. So we've got here a stylus. Depending on the user, I mean, I never use them, but you've got a stylus here. So if you like to use a touch screen,
okay.
You can see I never use it. Let's say we're in this menu, and if you want to type things, you can use a stylus. Rigaku also provides some tissue to give it a clean, and also a screwdriver. I don't expect you will ever need it, but I will tell you where it can get used. But what you should do once in a while, and the gun will tell you, it will say, please clean the window. So you've got these here, which are supplied with the system, and you either do them clean or you put a bit of ethanol, and you wipe inside of here gently.
Ethanol or
anything.
Alcohol.
Yeah. So it's just something that evaporates quickly, so you don't end up. We don't want to use water because then the water just stays there. But or you can wipe it clean. The reason why this is required is, of course, you are burning the surface.
Yeah.
If there's oil or anything, it is going to create fumes, which will eventually, cover the window. So this allows for quick cleaning once in a while. Okay.
And what frequency we should?
It will tell you.
Oh, okay.
Yeah, it will tell you. Okay. And if you ever have a problem with a failed system check, the first thing we will always tell you, clean a window. Now, this window is reasonably strong. I mean, it's sapphire, so, but people should not go with a screwdriver or anything like that in there, or you'll crack the window. And the reason why people give a screwdriver, in a worst case, you can take these two little screws out if you want to clean, but like I say, just like if you were cleaning your ears, you're not going to push like crazy. I'll do it again. I mean, these are all new and these are all clean anyway. It's a very, very simple. It gives it a wipe and off it goes. So that really summarizes the basic operation. Okay, you can see like all these things you can choose to log out, and this would be what the software looks like on startup. So to start, you have to type the code
144.
Yeah. Okay, and then pull the trigger just to acknowledge you are using a laser. You press the button and off you go. Okay.
Okay.
Right. So so that really is it. If we look in the menus, power off is quite obvious. System checks we've looked at. Settings. You can of course change some result settings. There's different things you can choose. At the moment, we've got a number of matches. So this is something for users to decide. Sometimes 2 or 3 grades could be very similar. So you can choose how many grades you will display. And let me give you an example of what that means. So if I measure, for example,
grades, you mean within one metal group?
Oh yeah. Oh yeah, absolutely. It will be within a metal group. So I'm now measuring an aluminium. And you can see actually this piece of metal is actually 5086. But it could be 5083, 5182, because the grades are so similar.
Yeah.
They actually overlap. Now, that's not really what I wanted to show you, but what I can do, if I keep on scrolling down, it will show me the next possible grade, 5056, 5754, 5052. But you can see each time the match grade goes down. Yeah. So that means the best match was...
31.
No, it was actually, it's gone the wrong way around. You can see the best match was this grade.
Yeah.
The next one we go down to 0.56. So but actually you can see.
And you can you drill down to improve the match? Next step.
Well, okay. So what you can do as a user, and what I would say in my result settings, I would reduce this maybe to 3. But you can force it to only display 1 grade.
Okay.
With these things, you or somebody will know what kind of users you're dealing with. You know with the scrapyard, some users, I'd say this sounds bad, but they have no brains. You don't want them to think at all.
Yeah.
So then maybe you will say only show 1 grade. But if the user understands a little bit, he'll say, well, this grade I've just measured never comes in the scrapyards. We never do this grade, so it can't be that. So then what you will say is, okay, I'm measuring it again. If somebody says it's not a 5086, impossible. Oh, well, is it a 5754? And then somebody say, yeah, okay, that makes sense.
Yeah.
Because unfortunately, some grades are so close to each other. I mean, if you analyzed the grade boundaries, you would see that they may be very close to each other, or the grade it is not in the library. Okay. So you need to work with the closest. Okay.
And what is how precise is the reading in terms of 0% whatever?
Unfortunately, it's not a fixed answer because it's different for every element. It's different for the bases. what you have to look at is the main purpose of this tool. Whilst it gives you an analysis, it's very much there to match the grade.
Yeah,
that's really what they're designed for. So I mean, actually, if I go back to the piece of, actually the error for each measurement is displayed by the width. So the error on the manganese is very, very small. Let's go back. Let's take this piece of Hastelloy. This is now Hastelloy. Okay. So what this is telling you now, the error of the nickel is about plus or minus 0.5%. The error on the moly is bigger. You can see how variable the error is on each one of these elements. But still, I know it's recognized it as a Hastelloy B. It's matched it perfectly. So the absolute error of the measurement is not always a problem. Well, it's never a problem because it matches the grades. If somebody is nobody would ever use this as a production control tool for steelworks.
Yeah. No, we have spectrometers for final product.
Yeah, that's it exactly. So this is really to help you check your scrap. Is it?
Yeah.
Are we mixing some zinc with some aluminium, things like that? This is very much what this is designed for. So from a basic user, that's it. And if you just show this, people can then get on with the scrapyard. A couple of things to be aware of, just in a practical terms. It's measuring the surface. So if, for example, you've got a metal plating on the sample, you have to grind it off. Because otherwise you will get the analysis of the plating, not the analysis of the bulk. And that's quite normal in the scrapyard.
Or rust,
rust. Yeah, if you've got really bad surface contamination, if it's really oily, if it's really rusty.
Of course, it needs to be cleaned,
a quick. People usually have an angle grinder or a Dremel, and that's something that you always have to factor in. Now, you have got... the measurement time is actually 1 second, okay? But the software's got different drill downs, and what that means, it's using the laser. I mean, it's all explained. You would say it's all explained in the manual. The laser can be used as a way to clean some minor contamination. So if you've got a little bit of oil, or if it's not too bad, it can clean it off. And drill down is written here. So we've got light, medium, heavy, or no drill down. My recommendation is always light, and I'll tell you why. Because heavy drill down is very good. However, it's now going to spend 10 seconds using the laser to try and burn off as a cleaning procedure.
Yeah, it's more.
But now the user has to.
More energy.
Yeah, it's more time, and you have to stay really fixed. The analysis works perfectly fine. It's very good. So only to use this. So what I do, I use this little button here.
There.
See the little button on the side?
Yeah.
And when I press it, it's changing. Now, no drill down is the quickest.
Yeah.
But
it needs to be clean.
Yeah, it's more prone to error. So it works on my sample. You saw how quick that was. I'll do it again. So quick. This is how long the measurement takes, always. Everything before that is cleaning. So if I put light drill down, can you see that there? Light drill down. So now it takes a couple of seconds before, and then it's doing the measurement. So for me, that's a very good compromise for most users. But you can change it. The users can change it. It's no problem. Okay?
Super.
Right. That really is everything you need to know. So do you want to try yourself?
Yes.